Hello everyone, I'm Mar T Barrete from grade 11 Turcos, STEM C. Today I will be discussing to you some application of integration in finding the volume of a solid. And here is the problem. The region R enclosed by the curves y is equal to x and y is equal to x squared is rotated about the x-axis. Find the volume of the resulting solid. By plotting the given curves y is equal to x, which is a line, and y is equal to x squared, which is a parabola, we will come up to a graph like this. When the y is equal to x and y is equal to x squared is being plotted, we can see an enclosed part, and that will be the region R. And it is said in the problem that is rotated about the x-axis. When the curves are rotated about the x-axis from this figure, it will look like this. It has a shape, a cross-section in the plane has a shape of a washer. And to illustrate further, it will look like this. We can see a two circle, the outer circle and the inner circle. We need to find the cross-sectional area by subtracting the area of the inner circle from the outer circle. But first, we all know that the formula in finding the area of a circle is equal to pi r squared. In this illustration, let x squared be the radius of the inner circle and x will be the radius of the outer circle. In finding the cross-sectional area, the formula is we need to subtract the AX is equal to area of the outer circle minus area of the inner circle. And now substitute the values, which it will now become AX is equal to area pi outer circle x squared, which is the y is equal to x, and minus pi the radius of the inner circle x squared raised to 2. And to simplify it further, it will now become ax is equal to pi x squared minus pi x raised to 4. But we can simplify it by getting the common factor, which is the pi, and it will now become ax is equal to pi x squared minus x raised to 4. And since we have now the cross-sectional area, we can now proceed in finding the volume of a solid. And the formula in finding the volume of a solid is equal to V is equal to integration of AX dx from 1 to 0. Why 1 to 0? Because we can see in the first graph that it intersects from the point 1 to point of origin. And substitute the values now, since for the area of the cross sectional, it will now become V is equal to pi x squared minus x raised to 4 dx. But to integrate this, we will use the first theory, which is the integration of x raised to n dx. That will become integration x n plus 1 over n plus 1. And to that we will use in this formula, which is it will now become volume is equal to integration 0 pi x 2 plus 1 over 2 plus 1 minus x 4 plus 1 over 4 plus 1. And it will now then simplify further. It will now become v is equal to integration of 1 0 pi x cubed over 3 minus x 5 all over 5. And since we have the maximum and minimum value, we can substitute it. We will use the 1 0 pi 1 cube over 3 minus 1/5 over 5. Substitute the minimum. 0 cube over 3 minus 0.5 over 5. And then cancel out since it has 0. Now, the volume is equal to integration 1, 0, pi 2 over 15. 2 over 15. We will only subtract the exponent. And simplify it further, it will now become 2 pi over 15. Therefore, the volume of a solid is equal to 2 pi over 15. And that's all, guys. Thank you.